come back to the source, so where exactly it goes. So whether it will broadcast, whether it will unicast, where it will do flooding.
It will do flooding, right?
So when it does unicasting, then
Unicasting means it will not come back to the source, right?
that's okay. But so
Not only
when unicast, so when does unicast happens, and when does broadcast happens? So when does flooding happens?
so broadcasting happens when we use hub actually.
Flooding, unicast will switch when we use switch. Unicasting will happen, right?
Mhm. Okay, so let me explain you again. So when we have the hub, right? So what happens? So when source needs to send the data to a destination, okay? So it will send the data across all the devices which are connected to hub, okay, and also to itself. So that's nothing but it's a broadcasting, and that's a drawback of hub. So that's the reason switch is an intelligent device. So when the devices are connected to a switch, so first time when source sends the data to the destination, okay, so first time it sends the data to all the devices, okay, which are connected to the switch except itself, okay, and from second time onwards it does unicasting, means only source to destination the data will be transmitted.
Yes.
Clear? All right. So today we gonna talk something about the addressing. Okay, so what is addressing and all. So I'll just share my screen. Let me know once you start seeing that. And regarding the documents and all, which notes and all which you guys are looking for, so I would advise you to just make a note of the things which we discuss. Apart from that, we're gonna share some documents with you guys related to this training program. Okay, and you can refer that. Okay. Let me know once you start seeing the screen.
Yes, I'm able to do that.
Okay. All right. Thank you, Aris. So today we're gonna talk something about addressing. Before I'll start with that addressing. So what I'm gonna do is that I'll give you a quick overview. All right. so so consider this as in my client PC. Okay, and from here I'm just trying to access uh, google.com. Okay, so the computer understands a language of binary, which is nothing but z and z in terms of 0 and 1. Okay, right. And again, this google.com is something mapped with some IP. Okay, it has some IP, which is nothing but its address. It's a IP address, internet protocol address. Okay, so we as a human, right? So if we talk something about this IP address, if we need to remember the IP address of everything, so this is very not tough job for us. Okay, so instead of IP, what does we do that? We remember the name of any website or of any server. Okay, if we need to access a google.com, I can go ahead in the browser and type google.com, right? But at the same time, if I need to access the same thing using the IP address, so it is very difficult for me to remember the IP addresses of the google.com website, right? And computer understands the language of binary, which is nothing but 0 and 1. Okay, so let's say this is my client machine or this is my laptop. Okay, and from here I have opened the browser, right? And I access this google.com, right? Now the request will go to my NIC, so which is connected with the internet. Okay, this is my NIC NIC card, Ethernet card. So this is now connected with the internet. Okay, what is this internet does, or we can call that as an internet service provider. Okay, so what does that do is like, it converts this website into the IP address, mm, host name into IP address, and then it will search. And again, this request, once it finds this the let's say this is a Google server, not MS. Consider this as an Google server. Okay, this is a Google server. What it does, the request will be forwarded to the IP ISP, and this internet service provider, what it does is like, it will check the IP address of the google.com, and accordingly it will communicate to that server via NIC again, because IP address will be mapped here for any device at the NIC level. Okay, if you want to see live where exactly the NIC and everything, I guess you can open in your laptop. You can directly type ncpa.cpl and you should be good enough in the command prompt. Okay, getting me? Yes, no, any
Yes.
doubts? Right. Okay, so again, for every device, okay, either it is a client machine or is it a server. Okay, so there is something called the IP address. Okay, so that's when we'll come to know that. Okay, so and this IP address is unique, just like our house address. Okay, so that's nothing but it's a physical address, but that is something unique. Okay, so if you are staying in a Delhi, in some place with some house number, so that is unique. You cannot have the same house number in the Delhi again or in the same locality, right? That is unique, right? Likewise, our Aadhaar number also, Aadhaar or PAN, those are unique. The same Aadhaar number or same PAN card number will not be assigned to someone else, right? So likewise, there is some likewise we do have the IP address. Okay, any doubts so far?
No.
Uma, any doubt? Understanding, not understanding? Or are you
Uh,
speaking on
I'm
mute?
I'm
I
trying
can't
to
hear.
following. trying to follow. Yeah.
Okay. All right. So sorry, I just shared my the screen. Let me stop and let me share my complete uh, computer. Let me know once you start seeing the screen. Okay. Okay. Are you seeing?
Mm, yeah, yeah, whiteboard. Yeah, run command I am saying right now. ncpa.cpl.
Exactly. See, this is the command that you can run in order to find out where exactly your Ethernet NIC card is. Okay. So right now this is what is connected to. So if I need to go and check the Ethernet card, I'll directly go to this properties. So this is my Ethernet card. Okay. So here the IP is by default. I'm getting it assigned from my router. Okay. This is where you check that. Now, now today we're gonna talk something about the IP addressing and CIDR notation. Will I'll take later. Today we just gonna talk about IP addressing. Okay. First of all, we start with the addressing. Okay. So addressing. Okay. So there for any system I'm talking about, or for any computer or any server. Okay. So addressing can be done, means it's in physical addressing and also logical addressing. Okay. So how the physical addressing can be done for a server? By using the MAC address, which is nothing but physical address for your device. Okay. Yesterday uh, I have shown you the MAC address. How do you find the physical address of the MAC address? By running the command get MAC. Okay. So MAC is nothing but the physical address. And when we talk about the logical addressing, so logical addressing can be done into two different ways, into IP addressing. Okay. And we have two different version of IPs here. IPv4, Internet Protocol version 4, and Internet Protocol version 6. Okay. So currently we are not using this IPv6 as of now. Okay. But this IPv4 have some lakhs of crores of IP addresses. Okay. So once it gets sent, so that's when we're gonna use this IPv6. So today we gonna talk about only IPv4 addressing. Okay. So this IPv4 addressing is further divided into two types. Okay. One is one is public IP. Okay. And second thing is private IP. Okay. So these IP. Okay. So these IPs are having of IPv4 is having 30 bits, 32 bits of IP address. Okay. 32 bits. 32 bits. Okay, and again it is divided into 4 octets. Okay, as we move on, we're gonna check this one. Okay, we're gonna talk more about it. So till now, is it clear? Okay, for any server, there are two types of addressing that we do have. One is physical addressing, and physical addressing can be done by MAC, by seeing the MAC address, which is nothing but the physical address. Okay, for device to assign a logical address, so logical addressing can be done to a particular virtual machine or any server. Okay, so that will can be done using two types. One is internet protocol version 4 and second is internet protocol version 6. So in our session we're going to talk about the internet protocol version 4, and this internet protocol version 4 is further divided into two types: public IPs and private IPs. Okay, but this public IPs, the internet protocol, the IPs which are routable over the internets are called as public IP. Okay, okay. So in any organization, okay, in an organization I do have a server, okay, and I do have devices. Okay, so these, all these will be communicated using the private IP. Okay, so now this server is connect, let's say this is connected to some router, right? From somewhere it needs, this server needs to get an internet, right? So this server will be getting an internet from the router, and this router would be connected to the internet. Okay,
Yeah, yes, with that, sir. Yeah.
this will be connected to the internet. So this router is having two IPs. One is public IP and one is private IP. Private IP is to communicate within the organization or within this LAN, right? So it uses the public IP which is exposed to the internet, right? So you might be having a question, why private IPs cannot expose to the internet, right? Why always it communicates over the public IP? For the security reasons. Okay, and also this IP, these are the IPs because over the internet we can have a same IP address. See, within the network, let's suppose I do have a IP of, I have a IP of 10.0.0.4. Okay, so outside of the world I can have the same IP address, right? But again there would be conflict and everything. So the IP addresses which are routable over the internet are called as public IP address, and if it needs to communicate over the internet, so that can be done using the public IP. So private IP is only meant for the communication among the LAN or within the network. Okay, clear? Not clear? Any doubts?
No doubts.
Okay, thank you, Harish. And how about Uma?
No, you can proceed. I cannot say that I am completely clear, but I am okay.
Mm-hmm. Okay, so all right, but you, in case if you have any doubts or if you are stuck at somewhere, just stop me and
Yeah,
ask me. I'll try to explain. Okay.
sure.
So if it is silence, so I'll think that whether you are getting everything or whether you are not getting anything.
No, no, if anything, I will like tell you. The thing is that when I am vague, okay, I know this is not the right time for me to ask the question because I know I am not 100% clear. That is why. So now you can proceed. I will read out some notes or something parallelly along with this, so it will be easy for me. Get that.
Okay. All right. So thank you, Ma. So Harish, it's clear, right?
Yes.
Okay. So what I'm gonna do is that right now we're gonna talk something more about this IPv4. The reason why I ask you whether you understood this public IP and private IP concept, because we'll be talking more. We'll be going a deep dive into this IP addressing. So that's the reason I asked you. So as you guys understood and Uma is trying to understand. So I'll just go further. But in case if you have any doubt or anything, just stop me then and there itself. Okay, I'll be more happy to
Yeah.
clarify the doubts. Okay, so right now, so we are talking something about this IPv v4 version. Okay, so this is nothing but this is 32-bit logical address. Okay, 32-bit 32-bit logical address. Okay, and it will be divided into 4 octets. You understand about the octets, right? The reason why I told about this bits, because computer only understand the language of binary, whether it is 0 or 1. Okay, and the IP address can have a range from 0 to, each octet can have a range from 0 to 255. So total there are 256 IPs that we have. Okay, and IP address is equal to, okay, it's a combination of network ID, okay, network ID plus host ID. We're gonna talk something more about this host ID, network ID, and why did I say like that. So before that, I would want you to just remember this thing. Okay, just mug up these things, because everything further, everything will be based on this. Okay, so IP address is of 32-bit logical address. Okay, and it will be divided into 4 octets. Okay, like 1, 2, 3, 4, 5. Likewise, we have 8. Okay, 4 octets mean 8, 8 bits, 8 bits, 8 bits, like this. Okay, so each octet is of 8 bits, and maximum value can have 0 to 255. Okay, and IP address is a combination of network ID and host ID. Okay, now we gonna, so let's say I have some IP address. Okay, uh, okay, so I have the IP address of 192.168.39.240. Okay, let's see. Okay, so each octet cannot have more than, it cannot go beyond 255. Okay, this is one octet. Okay, this can be further divided into 8 bits. Okay, but it is very difficult for us to remember in this 0 and 1 format, so that is the reason it is converted into decimal. And again, this is another octet. Okay, which is converted into decimal, because we cannot remember this in binary format. Likewise, the other 2 octets as well. Okay, okay, so how it is configured into octet, it uses the formula of 2 to the power n. Okay, and what is that 2 to the power n formula, as I'll talk about in a few minutes. Okay, when I give you some example and how it is being calculated. Okay, so before that, so remember these things. So how this 2 to the power n will work, like okay, it will be like 2 to the power 0, sorry, 0. Okay, 2 to the power 1, 2 to the power 2, 2 to the power 3. Likewise, it goes till 2 to the power 7. Okay, if we calculate that, so what it comes like 128. Okay, 64. Okay, 32, 16, 8, 4, 2, 1. Okay, so this is 2 to the power n formula, so which is being used in order to convert this binary into decimal. Okay, getting me? Not getting me?
Uh, yes, slightly. This is heavy for me.
Hmm. Okay, all right, Harish, are you getting me?
Yes, I'm getting it. Just recollecting myself.
Okay, see guys, simple. See, if this if you need to convert this 128 into binary format, how would you do that? You're gonna divide it with the 12. Sorry, you're gonna divide it with the 2, right?
hmm.
And from reverse order, you're gonna put 1 and 0, 0 and 1 format. So that's when we can convert this decimal into binary, and binary into, from binary to decimal we can use this formula. Okay, so if you need to convert, so for example, if you need to convert this, so what you need to do, 128 should be divided with 2. Okay, once you divide it with the 2, what happens? Two 6 are 12, 2 4 2 6 are 12, 2 4 are 8, right? So what is the remainder? Z- so likewise you need to calculate it, and you need to uh, convert this binary into sorry, decimal into binary by using the 2 to the power n formula, or you can divide it by 12, and you will be having that IP address in binary format. But so for this, let's say if this is an IP address 192.168.39.240, if I need to remember in this binary format, it is very difficult for me, right? 11111000, like, and I cannot remember. It's a very lengthy one. So that is the reason it's been converted into decimal, and 192.168.39 or 240 is something somewhat far better for me to understand and remember the IP address. Okay, so that's how the thing is, and further we're gonna go to this IP classes. So just capture the screenshot. I think also the recording is going on. Okay, so I'll jump into the IP classes now. Okay, so we do for we so when I'm talking about this IP classes and all these IP classes are related to the private IP. We are not talking anything about the public IP. Okay, so what do we mean by private IP? The IPs which are routable within the LAN. Okay, so that's nothing but the private IP, and we do have different classes of IP. Okay, so we do have 5 different classes. Okay, uh, class A. Okay, class B, class C, class D, class E. Okay, and these IPs are having some ranges. What is the class of IP? So in the previous slide you have seen some IP address, and by looking at the IP address we can identify whether this IP belongs to class A, class B, or class C. And here, by looking at the IP address, we'll come to know how many network IDs we have and how many host ID we have. Okay, so a host ID is where you can assign a number of IPs to the host or the end devices, okay, or the client machines or the servers. So those are nothing but your host IDs. Okay. So when we talk about this class A IP address, for example, so this class A IP address is having range from uh, 1.0.0.0 to 126.0.0.0. Okay, this is the range of the class A IP address. Okay, so if someone says I have an IP address of private IP address of 17.0.0.4, so which class it belongs to?
Class A.
Okay, because this range, so this for first bracket range, it falls between 1 to 0, 1 to 26, right?
Okay.
So that is the reason it comes under class A IP address.
Okay.
Class A IP address. Okay, so for the class B, we have a different range. It starts from 128.0.0.0 till it goes to 191.255.0.0. Okay,
Okay.
this is the class B IP address. Class C IP address starts from 192.0.0.0. Okay, till it goes to 223.0 dot, sorry, it's a 223.255.255.0. Okay, class D starts from 224.0.0.0. Okay, and it goes till 239, till 239. Okay, so likewise class E also, it goes from 240.0.0.0, and then it goes to 255.255.255.255. Okay, so in real time scenarios, okay, so the classes that we are using, we are using the classes of till from class A to class C. Okay, class D is basically used for multicasting, which we don't use and will not talk about it, and you won't find any class D IP address assigned to any particular host. Okay,
So, what about 127? It will not come under any class.
right. Well, that's a very intelligent question, Uma. See, yesterday I spoke something about the loopback IP address. Okay, so there is something called loopback IP address. So that loopback IP address, okay, so IP address 127 dot, I'll take you that.
127.1 that you asked to check the.
Yes, yes. This loopback IP address, okay, this is a loopback IP address. So what does it do? What does it do? Like in order to check your Ethernet port,
Yeah.
okay, NIC for NIC.
Yeah.
So that is the reason it is reserved for that. So that is the reason this IP is called as loopback IP address.
Okay. Okay.
Got it?
Got it.
Remember these IPs, okay, and accordingly we gonna calculate the, what do you call, the network host. How many how many network IDs we have and how many host IDs we have. Okay, perfect. Okay, I'll erase that and I'll just
Sorry, you were talking about that multicast, and I interrupt.
Yes, sorry. Yeah. So these IPs are basically Class D IP. Class D IP addresses are basically used for the multicast, and Class C IP address are used for the research purpose. And in in my entire career so far, okay, I never seen any these IPs are being assigned to devices which are connected over the LAN. These IP ranges. Okay, it won't assign to any devices because these are basically registered for this multicasting and research. So we mainly use the IP address ranges start from this class A, class B, class C. So remember, any IP which is starting from 1.0.0 till 126.0.0.0, it belongs to class A. Okay, so let's say I'm giving one IP address, just let me know from which class it belongs to. Okay, so which class it belongs to?
B.
Are you sure?
Yes.
Okay, how about Uma?
Yeah, it belongs to class B, right? From 128 to 191, it will be class.
Right. So how did you identify whether it belongs to class A or class B? By seeing this first octet.
Yeah,
Yes.
Okay, you just see this first octet and compare the same thing with this IP classes in which range it falls to. Accordingly, it will belongs to that particular class. Okay,
yeah.
perfect. Okay, so now I'm gonna talk something about. Okay, so remember this range, because it's now very useful for us to identify the IP address and its classes. Okay, so now how to find network ID. Okay, so there are some things that I'm gonna talk about. Uh, okay, so consider this, and this will be like mm, there are four octets, right, in an IP address.
Yes.
Okay, I'll talk about this. Don't worry. Two network bits and two host bit for this, and if it is a class C, three network and one host. Okay, so N denotes to network bits. Okay, network ID, and H belongs to host ID. Understand? Okay, and network ID always represents with N one. Sorry. Okay, network ID should be denoted with one, and host ID should be denoted with zero. Okay, or we can call it as network bit, not ID. I would say network bit uh, will always be represented with 1, and host bit will always be represented with 0. Okay, and remember these things. Class A would be having 1 network bit and 4 host bits. Class B is having 2 network bits, 2 host bits. Class C would be having 3 network bits and 1 host bit. Okay, got it. So now let's say you have, give you one example. Okay, so I have one IP. Okay, well, I have one IP. Let's say it's randomly 115.10, let's say 0 dot let's say 15. Okay, so first and foremost thing, just tell me from which class this IP belongs to.
Yeah.
A, right?
Yes.
Class A. Because if you see the first octet, this belongs to 115. Okay, so 115 falls under this category. This is a class A IP address range. So
Hmm.
this is a class A IP. It is clear, Uma? It's
Yes.
clear.
Yes.
Okay. Now for class A IP, how many network bits and how many host bits we have?
One network bit and three host bit.
3 host, right?
Yeah.
So whenever you have such issue, if someone says that, just let me know the network ID of this particular IP address. So in order to find the network ID, so what I would do, when it says 1, so the value should be as it is. It means this is a class A. So this is the network bit, this is the host bit, this is the host bit, this is the host bit. Okay. So what I would say, network bit will always be denoted with 1 and host bit will always be denoted as 0. So what you need to do is that in order to find out the network ID, in place of network ID, put the same number, because it is 1 denoted with 1 means the same value, and remaining host bits that you have just denote with 0. This is nothing but the network ID.
Hmm.
Getting me?
Yes.
All right. So I'm gonna give you one task. Okay, right now, just a quick practice kind of thing. Okay. So I would give you, let's say it's 150 dot 10 dot 10 dot 100. Okay. Now tell me from which class this IP. So Uma, please tell me from which class this IP belongs to.
Class B.
Class B. Perfect. Okay. And what would be the network ID of this?
It will be 150
Hmm.
to 1.0.0.
I didn't get you.
150.1 point.
Now, see, do one thing. So this is a class B IP address now.
Yeah.
Okay, now compare this IP address with this. How
Yeah.
many network bits and how many host bits we have.
Yeah.
Okay, so how many network bits you have? If it is a class B, there would be 2 network bits
Yeah.
and
Two
2
host.
host bits.
Yeah.
Okay,
Yeah.
right? So in the network bit, so what will you do? You'll write the value as it is.
150 point
Dot,
one point one.
not point 1, it's a 10.
10 dot
Okay, in place of host bit, what should be the value?
It will be 0
0 dot
0.
0. So this will be your network ID.
Okay. Okay. Okay.
Got it?
Okay.
Any doubts, any confusion so far? Just go through this one once. I'll give you one IP address. You can, accordingly you can check that. Switch on the light. Okay. Okay. So any doubts, any confusion so far? No? Yes.
No.
No.
Okay. Great. All right. So these are some ranges that we have in IP address. So in order to assign an IP address, so what you're gonna do is that manually you go to the Ethernet port. How would you go that? ncpa.cpl is a command from where you can go it, or else you can search in the search network adapter, network connection, or the Ethernet. Okay. See. Okay. I'll go to this properties. It's a lab version, I'm telling you. Okay, you'll go properties and here you will assign this IP address you have anything. But right now this is getting IP from directly from the ISP, internet service provider. So I'm not doing any changes. Okay. Otherwise, in any organization, if the server or if any client machine is connected via LAN, so I need to mention the IP address here. This is the public IP address, which is IPv4 version. Okay, guys, here come, go to the properties, and from here you can do that. IPv6 we are not talking about anything. Okay, so because it will be in the format of hexadecimal format. Okay, so great. I think you guys are now capable enough to solve any to find out the IP address of anything, right? So I'll give you one IP address, just make a note of it. It's a 213, okay, dot 267 dot 50, not 267, it cannot be 267, it can be 201, because the any octet value cannot go. See, this octet value, this octet value cannot go beyond 255. The maximum value of this would be 255 for any octet. If someone says that 128.258, so that is a blunder. Directly you can tell them that this is a not a valid IP address. Okay, the maximum octet value range should be up to 255. Okay, 0 to 255. Got it?
Mm.
Okay, so there is an IP address which I'm giving you. Just make a note of it and let me know the network ID of this. And let's say this is a 213.201.59.1. Okay, now tell me from which class it belongs to and what would be the network ID of this.
213.201.59.0 Class C.
Classy.
Class C IP address,
Yeah.
right? And this class C IP address, the what is the network ID?
N. Uh,
H,
yeah.
right?
Yes.
So what is the network ID now?
213 point
Mm-hmm,
201
mm-hmm,
point 59 point
mm-hmm.
it should be.
59.0,
Yeah.
because it belongs to the host. So network ID will still remains the same, only host bit will become 0.
Yeah.
So that's nothing but the network ID. Okay, guys.
Yes.
All right. Regarding subnet mask and subnetting, I'm gonna talk tomorrow. Okay, but before that, so today, because I would want you to just go through this IP addresses and everything session again. Just make yourself strong in that. Okay, so that's when it will be pretty easy for you. Okay, all right. So now I'm gonna jumping into a different other topic, next topic. So if you have any doubts with this topic, just let me know with this IP address and all, network ID and all.
No, no doubts from me.
Clear, right? Haris, I guess you are recollecting all these things now.
Correct, correct. I got that. I'm like, it's okay for me.
Okay, Omar, just go through the recording once and go through. I'll just check the document. I'll just share one document with your document link. Okay, so where you can read and go through that and understand. Okay, if you just go through this, my notes, the notes which I have written on this whiteboard, I think that should be good enough for you to understand the IP address and how to find the network IDs, what is the class and what is network ID and what is host ID and all. Okay. Logical. So the today's topic is next topic is logical topologies. So, so, so we have something called in this, we have logical in this topologies we have something called the star topology. First one star topology. Okay, so how, what do you mean by star topology? So let's say I have a switch. Okay, consider this as a switch. Okay, now I have this, there are four laptops or four desktops I have. Okay, so all this will be connected to a port on the switch. Okay, here, 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 and here. Let's say this is system 1, system 2, system 3, and this is system 4. Okay, this is nothing but the logic star topology. This is how it's connected like a star. Okay, and there are two, I won't say it's a logical topology, it's a star topology. And now there are two important topologies that we have. Two topologies model, logical topologies model that we have is, it has nothing, star topology has nothing, and we are not using in real time scenarios right now. Okay, so this is just to give an idea how it is connected. There would be a switch, and again to this switch there will be four system will be connected to a different port. Okay, if one needs to communicate to system 4, so it will communicate via switch. The data will be transferred to the switch, and from switch it will check the MAC MAC address of the destination device, and accordingly the data will be transmitted. Okay, and likewise if 2 needs to send a data to 1, so directly it cannot send, so 2 needs to send the data to switch, and with the destination MAC address. Okay, and accordingly the data will be exchanged to this, transmitted to this one. Likewise the communication will happen. Okay, so on, if you just okay, so next topology would be like our work group topology, work group model, topology model. So the important, this is very important, just remember. Okay, one is work group model. We can call it as like peer to peer. Okay, or stand alone model. Okay, so how exactly it will be? It will be just like the previous one which I shared with you. Okay, so there would be switch, and I have the some systems. Okay, so it should be connected via this switch. Okay, so 1, 2, system 3, the system 4, and this is connected with some switch. Okay, so this is nothing but one kind of network which has been established, right? If these devices need to communicate, so how they would communicate? They would communicate via switch. Okay, and this switch will be communicated with each and every device. So if any device needs to send the data, it will send the destination MAC address, okay, along with the data, and switch will be having all the MAC addresses of all the devices, and it will see in the data the MAC address of the destination, and accordingly it will transmit the data. Got it? So there is some advantage of this workgroup model. So what is the advantage? Like uh, it is suitable for the smaller networks. Okay, for smaller networks it is good enough, but when the network is very big, so it is very difficult to manage. Okay, and also the one good part is, like, here we don't have any rocket science or anything, any clumsy, so it is very easy to configure. Okay, right. So I'll give you an example, in real time example. Let's say in your at your home. Okay, so you have two computers. Okay, this is computer. Okay, or we can call as system 1 and system 2. Okay, if we need to communicate, if we need to establish a communication between these two, okay, so these will how I'll be using a switch. I need a switch when I need to communicate between three devices. Let's consider one more system, system 3. At my home I have three systems, and I need to establish a communication between these three systems. So how would I do that? I'll get one switch. Okay, I'll connect each system to this switch. Okay, and switch is an intelligent device. It has the data of MAC address of all the systems which it's been connected to, and accordingly now the networking has been established between these systems, between these three systems. So one system, one can send data to system 3, 3 can send to 2, 2 can send to 1, 1 can send to 2 can send to 3 again, but everything will be done via switch. So data has to come here, and from here switch it goes to respective systems or the destination one. Okay, and disadvantage of this, so of this workgroup model is like it's not suitable for the larger network. Okay, and when I say that's IT administrator or the server administrator, it is a very tough task for him, okay, to manage everything. And here there is no centralized system which has been centralized management system is missing here in this workgroup model. Okay, you can make a note of the advantage and disadvantages which I'm telling you. Uma, Harish.
Yeah, sure.
Okay, so advantage of workgroup model would be it is suitable for the smaller network, and it is easy to configure. Okay, when it comes to disadvantage of this workgroup model, it is not suitable for the larger network. For a smaller, up to 3, 4, 5, up to a smaller network, it's okay, right, up to 10. But if it is going something 100 of servers in real time scenarios, the client would be managing the hundred thousands of servers. So it is very difficult to manage this model. workgroup model. Okay, so it's not suitable for the large network, and admin task is very high. Okay, and centralized management system is missing here. Okay, security will also be missing here. Okay, so in order to overcome this workgroup model, we have something called domain model. Okay, if you want to see the perfect example of workgroup machine is our laptop. It is not connected to any domain. Okay, if you type the command in the run sysdm.cpl, sysdm.cpl, if you hit enter, you'll see, sorry, this is a domain one. This machine is joined to the domain, otherwise it will show as a work group here. Okay, and practically I'll show you what is work group model, and where we can see whether the server is joined to the machine is joined to the domain or not. Okay, so this is joined to the domain. Okay, so in order to overcome the work group model, so we have something called the domain model. Okay, so in domain model, what will happen, we'll be having a switch. Okay, and we have some active directory domain controller we have. Okay, the switch. I have some other systems also. Okay, and all these are connected. Domain control is connected to the switch. Okay, and the system is connected to the switch. So what is the advantage of this domain controller is like, so it will manage the complete user details, the complete computer details, the objects and everything. So when it is connected to the switch, the MAC address of the system 1, system 2, system 3, system 4, all the systems which are connected to the switch, so all this information will be stored here at the domain controller. Okay, and it will be easy to manage. Okay, so because it is having some storage kind of thing, storage file which is nothing but in ntds.dit file. ntds.dit, this is the database of the domain controller or active directory, because this domain controller is having the information of all the computers, all the objects, all the devices, even also the switch information is also there on this domain controller. Okay, uh, so that's all for today. If you have any questions, let me know, because tomorrow we're gonna talk something about subnetting, and I'll show you the live how do we configure the domain controller. Okay, so where do we check whether the server, whether the machine is a workgroup model or whether it is a domain model. Okay, we'll jump into this tomorrow. We're gonna install the domain controller. Okay, and we will configure it, and we'll see the authentication, how the authentication will be done. Okay, and also how do we configure this member server and all. Okay, how do we create a user and all. Okay, so we'll cover the same in tomorrow's session. Okay, so, any doubts or anything? Haris, Uma.
No,
Are you
maybe
guys there?
to share the notes or anything. I will just go through it once again. Then I
Hmm.
come back if any doubts.
Because the thing is that, Uma, if you are missing somewhere, okay, if you are not clearing your doubts, then in there itself, then again it will be very hectic for you.
No, not at the point. The point is
I understand.
not in a
I,
position to ask doubt actually. So I need to okay set this up.
no,
So
no.
my-
Even if you're not understanding, so I'll try to explain 10 times also. I don't have any issues. My point is that, so when you're getting trained out of here, right, so that's when you should be in a position that you are managing the environment, the server infrastructure, the Azure infrastructure, everything, at least of L2 level.
okay, okay,
Okay, not even at L1 level.
okay.
Okay, so that is the reason I'm multiple times I've been asking whether you have any doubts or anything, because these all the things which I'm talking about, the basics. So if you don't have the understanding of these things, and if you're directly getting trained on the Azure, it will be very difficult. We really don't know what exactly, because that will be at the higher level.
What exact my situation is right now. I am lagging, I know very well. But the thing
Hmm.
is that I will go through the video once again. And if
Hmm.
possibly, if you share some notes, no, I will be able to coordinate it. So tomorrow I can sync along with the class actually. So
Okay.
just give me 1 or 2 days. I will pick up actually. So, but it would be great if you can give me some notes so I can correlate. I will read and I will see the video. No, then I will get my base will be good actually.
Right.
Okay.
Understand. No worries. So regarding, there will be links that we do have. I'll be sharing over the WhatsApp. Okay, you just go through that link regarding this IP address and all.
Yeah, because
Okay.
I tell that I am from a computer science background also, so it is a very very long back actually. So for me, I don't want to
I
wander
no
when you
no.
take the
I
class.
understand. I understand. No, no. Whenever you have a doubt, just ask. No worries.
Sure, sure.
Okay, you just note down all the doubts. So when before we start the class, you can ask, or
Yeah,
in between also you can ask, or post the session also you can ask.
yeah, sure. Thank you, thank you.
Okay, no problem. How about Harish? Are you following us? Are you able to following me?
Yes, I'm able to follow you.
Okay, so it's easy or is it difficult?
No, like yes, this topology model is old. Like old means uh, like not to recollect also. I forgot it. This class A, class B, class C was easy for me. I remember it because I have been using topology models. Just for basics, I used to read it. And now I forgot, but just now recollected. I will anyhow see once again this video.
Okay, please go through that. The important is like the domain model and the workgroup model. Okay, so these are the two
Mm-hmm.
topologies that are being used in the real-time scenarios. Okay,
Okay,
yeah.
sure.
All right, guys. Then that's all for today. We're gonna meet tomorrow. I think tomorrow I'll share the the class timings and all tomorrow. Okay, no worries, helping. Okay, if any
Done.
deviation is there, I'll let you know. So, and also, are you guys available during the weekends?
Yes, I'm available.
Only if you guys are interested. So that's when we can conduct the session. Otherwise, we'll start from Monday. So that's right.
Yeah, I'm okay with weekends. If anything is there, I can let you know in the morning time itself in the WhatsApp group.
Mm-hmm. Okay. Okay. No problem. So we can